Y is very specific. It's special. And an analogy in teaching this that I use is going to a Coke machine. Let me draw it for you. A Coke machine. Again, leave some space below function. I'm going to help define it with words after we talk about the Coke machine, okay? Coke machine. And let's see, what are some buttons we have? We have Coke, obviously, since I said it was a Coke machine. We have Coke button 1. I'll say sub 1 because I guess sometimes they'll have more than one of that one. It's a pretty popular beverage to choose from this machine. What else is in a Coke machine? There's Coke button 2. Diet Coke. A function of numbers works a lot like a functioning Coke machine or a working Coke machine. You push a button. How many drinks do you get out? 1. Okay, good. So if I push the Coke button, what am I hoping will come out of this thing? Coke. Nice. Now, do I have more than one way of getting a Coke? I mean, do I have more options on what I can push on input? Sure, there's 2 Coke buttons. That's okay, though, isn't it? I can get a Coke. I can get the final result of a Coke 2 different ways. Sounds still like the machine's working, right? Push this button, get your nice Coke. You guys are going to be like thirsty for Coke in a second. Push this button, still get your Coke. 2 different inputs, 1 ultimate output. That's still safe, still legit. If I push the Diet Coke button and I get a Diet Coke and a Dr. Pepper. So I push one button and I get 2 things. Is that okay? No way. Coke machine people are going to be mad they just lost some money. The machine's not working. This is bad. Bad. Broken machine. This is acceptable, though. It's acceptable to push 2 different buttons to get the same outcome, but if you push one button and get 2 different drinks, something's wrong. You just kind of cheated the Coke company if you took them both out of the machine. What about Dr. Pepper? Is it okay for me just to have one option to push Dr. Pepper and it gives me Dr. Pepper? Sure, who cares? You don't have to have more than one option. You can just have one option. This is also good. The way a Coke machine functions is very similar to how we say numbers function. X and Y function. A lot of times when we talk about X and Y, we will say that X is our input variable. It's our button. X is input. In this analogy, it would be our button. Y is what we get back out of a function. It's our output. Y is equal to output slash the drink we got in this analogy. Something else a lot of times mathematicians will point out at this point is when you're talking about X and Y, these numbers that we're going to say work in a special functional way that we're defining, they'll say, you know what I'm drinking is going to depend on which one, the button I push or the drink in my hand. What's the number one thing that's going to tell me what I'm going to get in my hand? It's the button, right? This input can also be known as the independent variable. It's the one that's going to change my output. So in addition to calling X an input, you could also call it the independent variable. What would that make Y? Dependent, yes. It depends on which button I push. Or it's the output, whatever makes you happy. So I'll say X is independent. And Y is dependent on X. I guess I should put the word variable. Variable, because when they define it, they like to throw that word there just to make sure you're okay knowing it's a letter. Okay? So far, I think we're acceptable, right? You guys okay so far? Let's take this analogy of a working Coke machine, though, and set up some rules for this function that I'm telling you what a function is, for this definition. Tell me about it, guys. If I have x's and y's, can my x's repeat? Can I have two of the same x? Sure. Can my y's repeat? Can I get double y's? No, you can't get two y's coming out. So in fact, actually, it might have been better if I put Diet Coke, Diet Coke. You just can't get two, not okay. That doesn't matter. Okay? For every button I push, I cannot get two things out, right? So I'm going to word it like this. For each x, for each button, I have only one y. For each input, I have only one output. In other words, x's can repeat, but y's can't. Let's look at some more examples that aren't Coke machines and see if we can recognize functions. Let's say, for example, I know there's a lot of vocab being thrown at you, but I'm going to actually add one more thing while we're doing this. But I'm going to say, hold on, I don't want that one. Okay, I'm going to say my x's are 2, 4, 6, 10. This is called a mapping. When I visually kind of draw you pictures to show you what belongs together, that's what they call this. And when I was in math, guys, I'm just going to be straight with you. It used to drive me out of my mind. Because I thought, I don't want to see pictures, give me the function. This is one of the conceptual ways of learning it. Don't let it freak you out if it does, okay? We're just talking about what kind of things are allowed. And I'll show it to you in regular numbers, too. Here are my y's. So I've got two bubbles of numbers. And I'm going to tell you this is what happens. For my 2 button, I'll get a 3 when I press the 2. Still okay? Input, output. For my 4 button, I'll get a 6. Is that still okay? For my 10 button, I'll get a 6. Is that okay? Go back to the Coke machine. Can I have 2 of my inputs pointing to the same output? 2 different Coke buttons push into a Coke? Look, I got it happening. I cannot have one repeating. I'll show you an example of the opposite in a second, okay? But yeah, I can have 2 coming and going to 1 Y because it's still unique. I'll show you what I can't have in a second. And 6, I'm going to say, goes to 8. I'll say versus, let me give you another situation, these same number options. I'm telling you, I know it used to hurt my brain too. It depends on the kind of learner you are. But this is the way they teach functions, so I'm going to talk you through it. Here are my x's, here are my y's. Let me give you a new relationship, and you guys tell me if it's okay. I'm going to keep 2 to 3, and I'll keep 4 to 6. That's still fine. But this time I'm going to say that 4 also goes to 8. Is that okay? Go back to the Coke machine. If I pushed one button, can it go to 2 different outputs? No, it's broken. If I push a Diet Coke and get 2 drinks, it's not okay. The machine's not working. If I push a 4 and get 6 and 8, the machine is broken. The Y's cannot repeat. Do you see them repeating? 6 and 8. You have 2 Y's for that 1 X. Let me keep drawing. Okay, so then we got, who cares? I'll say that 6 goes to 8. That's perfectly legit. And I'll say that, where should we point 10? You want to point to 8 too? 8's popular. But the point is that what's not okay is this right here. That's what's not okay. Not allowed. That makes this not a function. We don't care how many times 8 gets pointed to. We just care that from one button, you don't go to 2 things. From this 4, when you pushed it, you can't go to 2 different things. It has to be a unique mapping between your input and your output. Just like on the Coke machine, you push one button, you better only get one drink out. We don't care how many ways you can get to that Coke, how many Coke buttons you go on the machine. We just care that it's a unique thing for each of those. Let me show you what the ordered pairs look like. I bet you guys can actually help me generate it. Let's see. For the first example, if I wanted to list out the ordered pairs in another way that you could see them, I would have that 2 goes to what? 3. Then what? 4 goes to what? Then what? 6 to 8. And 10 to what? Okay. Here's your relation. Here is your group of ordered pairs. Over here, let's make this one. We have the 2 goes to what? We have the 4 goes to what? 4 goes to what? Okay, 6 goes to what? And 10 goes to what? In the definition, when we defined it, when you're just looking at the numbers, what are you making sure doesn't repeat? Wait a second, did I say it backwards? Yes, I did. Let me fix it. X's, sorry. X's cannot repeat. I'm sorry I wrote it backwards. Good thing I backed up to the highlight. You guys have been hating me for sure. The X's cannot repeat. So even though we've talked about the visual representation of one button going to 2, if you're looking at the ordered pairs, the relations, these little sets of X's and Y's together, this one right here works. Yeah, we have 2 Y's. You know, X, Y, X, Y. We have the 6's repeating. But that's A-okay, isn't it? You're just looking to make sure you don't have X's happening over and over, aren't you? Over here, what breaks this one? What repeats to break it? The 4. Your X's repeat. They can't do that. That's the definition. Your X's are not allowed to repeat. So this one over here is A-okay. Do you guys see the difference when you look at it visually or if you just look at the numbers? If I asked you, is it a function, you look for one button pointing to 2 things or your X is doubling up, your X is repeating. Either of those things means it's not valid. Now, guys, were we required to have 4 and 10 both pointing to 6? Or was that just okay but not necessary? The Coke machine does not have to have 2 Coke buttons. Who cares? Who cares if there's 2 ways to get the same output? The idea is, sure, you can have 1 to 1. Sure, you could have had erase that 10 off the bottom. Erase this point, where everything has one single unique thing. That's fine. 1 to 1 is definitely okay. Note, 1x to 1y is okay. It's actually called something special. It's called 1 to 1. And it's special. It's something you'll care about later in mathematics. For right now, whatever. As long as you don't repeat those X's or have one button shooting 2 different things, 2 different Cokes or whatever this thing is we're talking about, you're fine. But this one right here is even more friendly. When you have 1 Y to 1 X only, it's mutually exclusive both ways, 1 to 1. That's a really good function. That's a really strong function for you. Let's talk a little bit more about the picture of what these look like, the graph of what these look like. So I've given you these weird bubbles and said, oh, let's point arrows. That's fine. I guess we're kind of transitioning into something concrete. The numbers, if I were you as a student, I would remember this really well. This is something pretty big deal.